In this video, we're going to talk about how you can determine whether or not a data set fits a certain type of assumed distribution. Okay, so if you did a normal distribution, if you assume a normal distribution, does your data set actually fit a normal distribution? Okay, so in order to do this, there's 4 steps that you need to take. Okay, first step is we need to construct a histogram. Okay, the second step we need to do is calculate the number of degrees of freedom for a data set. The third step is we need to determine the number of predicted occurrences within each bin within the histogram. Okay, and then we can determine the overall chi-squared of the entire test using the following formula that's shown below. Okay, the lower the chi-squared value, the better the fit actually fits the expected fit, and the higher the chi-squared, the poorer the fit. Okay, so we're going to test our hypothesis here that the variable x is given by the measured data. All right, and it's described by a normal distribution at a 5% level of significance. Okay, so let's go back to our data that we had in table 1. Okay, so our data set is shown on the left-hand side here. All right, so from this data set we can create a histogram. Okay, we did this in an earlier example. Right, we had 7 bins. Okay, we defined a range of each bin of 0.1. Right, and we started the lowest part of our histogram was at 0.65 and the highest was at 1.35. Okay, based off of the histogram chart, we can determine the number of points within each part of the histogram. All right, so we get 1 through we get 7, so we have all the data for each bin of our histogram. Okay, so once you have the data, awesome. All right, second part of it, the problem asks you to determine the number of degrees of freedom. All right, so in this problem we have 2 restrictions. All right, those 2 restrictions that we have from the data set are the mean and the standard deviation. We need the mean and the standard deviation in order to calculate a few things about our data set. Okay, in our case, we needed both those values to determine what is the overall bin probability, like the overall chance that random data would be between the lower bound and upper bound of each bin in our case. Okay, so since we needed both the mean and the standard deviation of our data set in order to calculate that, our degree of freedom, our number of bins minus those 2 restrictions gives us our degree of freedom value of 5. Okay. All right. The third thing we need to do is estimate the number of predicted occurrences within each bin. Okay. And in order to do that, there's, I guess, three steps that are involved. The first thing we need to do is calculate the lower bound probability. So to calculate the lower bound probability, we need to use the mean. We need to know what's the lower bound. All right. We need to know what is the mean of our data set and what's the standard deviation. All right. So we can do that for all of our data sets. All right. And we can do the same thing for the upper bound probability. Okay. So we just use the upper bound value. All right. And we carry that through. All right. All right. And then the last thing we'll do, or the last 2 things we'll do is we'll subtract those 2 upper bound and lower bound to give us the probability of data point for normal distribution landing between 0.65 and 0.75. Okay. Once we get that value for all of our bins, all right, what we can then do is multiply that probability by the number of data points in our data set. So we had 20 data points, so we multiply each of these by 20, and we get the expected number of points within each region. Okay. So the last step that we have is we need to use the number of data points within each region, the expected number of data points, and the actual number of data points for the histogram to estimate the chi-squared value, overall chi-squared value. So in order to do this, we need to use the formula that we talked about at the start of the video, where we take the difference between the current number of points, the actual number of points in the histogram, and the expected number of points in the histogram, square it, and divide it by the number of expected points in the histogram. So we do that for each region, so all 7 bins of our histogram, and then we take the sum of all of those values. Okay. Once we take the sum of all those values, we get our p-value, right? And we can get our p-value from the chi-squared value. So the only things we need to do in our we need to determine our p-value is the number of data points the chi-squared value and the D32 value and the number of degrees of freedom. Okay, so once we have that, all right, we have our p-value, all right, and the p-value is the most important thing, all right. So if our p-value is less than 0.05, we can reject the null hypothesis. Since it's greater than 0.5, we can say that the data set follows a normal distribution. Okay. If you have any additional questions, feel free to look at this reference. At Statology, they do a good job of explaining the chi-squared test and how you can use Excel to evaluate it.